Hi everyone, it's a pleasure to be here. It's a pleasure to welcome you to another seminar in our seminar series, Perspective Using Artificial Intelligence. We have today a very nice guest from Africa. It's Professor Vukosi Marivate. Professor Marivate is an associate professor of computer science, holds the ABSA up chair of data science at the University of Pretoria in Africa. He develops artificial intelligence methods to extract insights from data. He works more particularly in the intersection of machine learning, AI, and natural language processing. Um, he's done work on natural language processing, machine learning, knowledge representation. He's a leader of the Data Science for Social Impact research group in the computer science department at the University of Pretoria. Professor Marivate is also a co-founder of many enterprises. He's a co-founder of a startup called Lelapa AI, focused on AI for Africans. He also a co-founder and an advisor of the Mazakani Research Foundation, foundation that aims at supporting natural language processing technologies for African languages, and also a co-founder of Deep Learning Indaba, grassroots conference for African AI researchers. That aims to empower and support African researchers and practitioners in the field. So it's very nice to have Professor Marivate here, remote, but the floor is yours, Professor Marivate. Thank you.
Okay, thanks. Thanks for having me here. It's great to see virtually. I think people at this event will present. It's been a bit of a long day. I'm in Cape Town today at a couple of meetings. So it's the evening in South Africa. It's about 9 p.m. But I really look forward to this presentation, and thank you also for the invitation again. So I'll be talking about how we center African languages in the current AI revolution, and talking through the experiences of especially kind of the last few years through our research group at the University of Pretoria. So thanks for the introduction. Yes, I do wear many hats. And most of this is because I'm really trying to think about how really do we make an impact and changes to our languages. So to do that, it means that, yes, I'm a researcher, but at the same time, I have to think about how do we sustain an ecosystem across a continent and then build on for the future, because especially for our languages in the global majority, and I'm pretty sure also the same in a lot of Brazilian languages, we are very near extinction. So you need to figure out how to resolve many, many things all at once, as opposed to just in piecemeal. So at the University of Pretoria, I lead this group, the Data Science for Social Impact group, where it's a mix of students, postdocs, and staff. Most of the work that we do is in natural language processing for African languages, and we do some work in data science and society, especially in thinking about how do other people get to use artificial intelligence and data science who are not really the experts like ourselves. So just as I know this is hosted by the Center of AI, but I just wanted to kind of especially highlight when we're thinking about AI from a definition perspective, where kind of data sits in before we start going into the language piece. So in general, we've got the AI definition from Norvig and Russell. You have an agent, it lives in some environment, can take action and achieve some goal. With that, you can have a robot vacuum cleaner in a house, which is the environment. It can move around, it can vacuum, and the goal is to keep the house clean. You have machine learning here. Specifically, if I think about supervised learning, you can have data on a plane, 2 dots, one being red and one being blue. I ask you in the future, can you then tell me if another point drops, what color would it be? And what you would want to do is learn a decision boundary. The simplest one is a straight line, which is equidistant between the 2 points. And anything in the future that's left, I'll predict that it's red. Anything that's on the right, I'll predict that it's blue. The world might not be that simple. You would have your data is a little bit more complex. Sure, in this one here, I'm not showing any kind of mixes of the dots, but that what happens is that your decision boundary becomes more complicated. So this one would be like some quadratic function that you have in here. We will make that jump that on the other side that you can train these huge models with deep learning where you can have a model that can take in an image and then on the other side then come up that it's a dog and not a cat in the picture. Why do we live in this world right now? Is that without machine learning, obviously you would have to write all this program and explain what it is that you're processing as input, and then actually then be able to then predict, come out with an output. But with machine learning, the biggest thing that we focus on is identifying these examples, this data, whether it's for supervised learning, unsupervised learning, regression, all these different kind of pieces that we would like to actually do. So we are now kind of jumping into the current state of a lot of AI, and we are in this point where now we have this insatiable appetite for data and compute, right? And in some ways, maybe the compute is scalable, and that compute keeps on getting better and better in one way or another. But the data has challenges, especially when we're going to come to talk about our languages. So we must acknowledge that what is old is new. This is not the kind of the first major AI revolution. We've had a number of these AI summers. We're just in this age of generative AI right now, and it won't be the last one. But then we also have to learn from the past to get a grip of what actually is likely to happen in the future. There's a lot of arguments now that are starting to be made about, like, we're starting to reach plateaus, especially when it comes to thinking about language models, especially in English. But it doesn't mean that the same thing is happening to our more local or low resource languages. So there will be all this change we have to go through. There's many ideas that are floating around. Many will wither away, but then the ones that float to the top, we have to think about. Another way to place where we are in AI today, if you think about archive and how many papers are showing an archive, it was just a decade or just over a decade ago where you would have maybe 100 papers on archive per month that had to do with machine learning and AI, and now we're probably over 150 per day. So there's a lot of research that's going on and many things to kind of read about. But the thing, as I said, like I'm interested in, a lot of us are, is thinking about low resource languages in these spaces. At the same time, you also have inequality when it comes to access to compute. If you look at this is A100 GPU counts, depending whether they're, this is national high performance computers, private cloud that companies have only for internally for themselves, and public cloud where you can access outside. So as of February 2024, you can see here Meta, Tesla had kind of a lot of these A100s and a few mix of national HPCs. But if you go a generation later, H100s, we, in terms of public information, we're now looking at less and less featuring of national HPCs, and you have a lot of private a cloud and some public cloud. And obviously here you have an anomaly, right, where Meta is really controlling a lot of GPU compute when it comes to H100s. And the other challenge here is obviously we're now the kind of more latest generation H200s that are starting to come out. And this is still something that's going to be a major issue thinking about going into the near future. So compute is also unequal, right? So you're not even talking about national HPCs anymore. So thinking about how that is going to be accessed is something we have to think so. When we think about data, we then have to think about where does the data come to train all these models? Does it represent us? Might it have bias? Does it really carry the values that we might have? How also do we protect private information? And for me, in thinking about Africa in these spaces, and maybe if thinking about also in South America, Brazil, we don't want to just become these cheap data markets, right? Where people are like, no, we just get data, we become consumers, and then we're not thinking about actually shaping these technologies as well. So if we think about these LLMs, you're now at the size, like, where you have very, very big models, and they continue becoming bigger and bigger and bigger, requiring more and more data, because we now, like, not that we now know, looking at this paper from a couple of years ago, that showed that, like, the gains that you get as like, from higher quality data is better than the ones that you get from compute or better algorithms. So you want to keep on getting more and more data to train your models. So if you think about language, for example, let's think about Wikipedia as a heuristic of availability of data. So if we look at all of Wikipedia's by the number of articles, there's English. It has like 9 million. 7 million, almost 7 million articles. And then you start going down, you see French, there's Swedish, there's Russian, there's Spanish, and now you're at 1.6 million. So if I think about South African languages, sorry, I didn't check Portuguese. I should have, but then there's Swahili, and you're now moving from 6.8 million articles to 80,000 Swahili in East Africa. There's Yoruba in Nigeria, 33,000. There is Zulu, one of the almost 25% of South Africa speaks Zulu in a country of like 60 million, and it only has 11,000 articles in isiZulu on Wikipedia. There's Sesotho. Sesotho, remember, there's a whole country of Lesotho, and it only has 949. So now if we think about the availability of these tools, it shouldn't be a surprise that it's hard to get very good natural language processing tools in Sesotho compared to English. But it doesn't mean that it's not worth actually creating those systems. So there's things that have to change. So for something to take is that it's not just about the data, but it's also about people, right? Data is about people. So we need to think then for these models or the data that gets created in these spaces, who benefits? So there's now more and more discussion about data licensing. How do we also make sure we capacitate locally, that people can actually do this work in a local way? We need to have a right to research, to allow academic research, so we have access to data to do our research. Better licensing by government or public, public entities, so that researchers can get access to data that comes from there. And things like fair use and fair dealing, meaning the thing that really enables that in some markets you can scrape the internet and then use the data is because of this fair use, right? But then there's fair dealing, meaning that if you do then make money out of that, you then have to then engage with the copyright holder to also make sure that they are also getting a part of the deal. On another side, right, we need to then protect communities. We're not just a data market. I'm a cheap, annotator. We need to protect workers and compensate them fairly as they're doing these things. And on the African continent, we've had this challenge where there was a whistleblower about a year a bit ago, where in Kenya, in Nairobi, there was this revelation that a company that was doing a lot of work for people like OpenAI, for Facebook, there were no protections. They were doing a lot of content moderation annotation, and there were no protection for the workers in terms of getting healthcare, getting mental health support. Because if you're doing that work, for a lot of times you end up being that you're literally seeing the worst of the internet, and people should be protected in those spaces. And what tends to then happen is that for a lot of organizations, they're always just looking for the cheapest place to do this. And this then means that it correlates with places where there might not be good labor protections. There might be lax enforcement of regulation or policies in terms of protecting those workers as well, right? At the same time, licensing discussions must happen, right? We need to think about how we navigate these challenges that we're thinking about, where data comes from, how it's used, and really how people get fairly compensated. We also want to protect our heritage. We want to enable an ecosystem and need to balance power dynamics. Why do we think about licensing? So I've hopefully convinced you that there's the whole inequality in terms of compute. So right now, if we just think about data and we're just saying people are creating data on one side, the exploitation of that data would then kind of move to people who have compute. So if you don't have compute and you have data, then there's an imbalance, because then if you just release data and you're not thinking about the licensing, the people who benefit the most are the people who have the compute. But at the same time, you might want to enable an ecosystem and say, like, no, I would like the people around me, maybe who are Brazilian, who are thinking about building these things, who are very, like, who are startups and all those things, to have access to this and use it to come up with new innovations. But if you have very, very large companies who have a lot of compute, a lot of the money in these spaces, they must find a way to then, fairly compensate for accessing this data. And thus that creates this tension that we need to think about, right? Because we are trying to think, oh, only open data, oh, only open models. But this then leaves on one side that there's not this discussion about how we really balance these power dynamics that come in on this side. And that's becoming more and more of a bigger discussion that people have to have, and they must happen. It is not something we will think about, 10 years from now, 5 years from now. This is the time to have these discussions, because we need to resolve this, especially for the global majority in spaces in developing countries, that people are trying to navigate these kind of things. It's not just a discussion that is had by the very rich countries. It has to happen everywhere, and also involve communities who should have and do want to be really participate in these processes. So after that kind of introduction in that background, I would like then to think about low resource language NLP research. So the reason that you say that is that there are low resource scenarios of NLP research. So you might think about doing research in language in health, where it's hard to get health data. But in this one specifically, I want to think about languages. So there are lots of challenges that low resource languages find themselves. So low availability of resources, hard to discover these resources, maybe hard to reproduce some of the work. Focus. So some people might want to focus on very high resource languages. My understanding of Brazil, you might have Portuguese as being the language that's kind of everywhere. But if you think about regionally and specific communities that have languages that might not be spoken everywhere, but then you want them to be represented within these systems, they become very low resource, because people might say, oh, I'd rather focus on Portuguese and not focus on these other languages, because people might understand better what my results are, for example. And this creates, again, this inequality, benchmarks, and then scale of complexity of really doing work in these spaces. This very nice work from Joshi et al. Look at classifying languages. So you have English, Spanish, German, Japanese, and French. Maybe about 2.5 billion uses seven languages, accounting only of 0.28% of these languages, and they were classified as the winners. While if you go down, there's isiZulu, as I said, again from South Africa, as part of the languages that are maybe hopeful that they could improve as time goes on. But the bottom languages that represent 88% of the languages that are being evaluated in these spaces are really the left behind and might go away or get extinct as time goes on. So the problem, the situation is dire at the moment. The African continent has 2,000 plus languages, and thinking about how these get represented is very important within kind of these natural language systems and tools. If I think about South Africa, for example, this is just a kind of a different way to think about the earlier Wikipedia example. So these are South African languages. And for example, isiNdebele is a language, my wife's language. It's only now, I think, starting to get Wikipedia articles because of an intervention actually by the government to get that to get these written. But if you look at isiZulu, as I said, I think right now with the latest census, I don't know if I have it here, no, it's at about 25%. And it only, at that time, it had 1,000, and now it's moved up to 10,000, which is great in a couple of years. This was, I think, 2019 or so. So it's going to about 10,000. But there's still more that has to be done kind of in these spaces to bring it up. And it's something that's important for all of us. Many countries in the global majority or global south are affected also by the history of colonialism, right? It touches on language and the way that we actually experience AI today. The resources we have today are affected by this history. a lot of resources actually were produced by Christian, missionaries. So you might find that for a lot of languages, the first time they were written was actually to try and do some translation of a holy scriptures so that to convert the local population. It wasn't about really being, hey, this is the best way to write this language or the best way to represent this language. It was mostly for that. So this then brings in that local languages might have been looked down upon, and you then have these experiences that, for some of us, you might have been gone to a situation where you were even forbidden to speak your language, right? And then this sometimes might have been at a school when you were growing up, and because it's part of these kind of power dynamics in these spaces, right? And language does become this war zone that you need to think about. So Ngugi Tiongo talks about this in Decolonizing the Mind, this book, like a very seminal book, that we also must think that language is more than just symbols. It is not just you can replace one word with another and it means that you kind of understand everything. It's culture. It's really, it carries geography. It carries many parts of community, and as such, it is, when you're losing a language, you're losing more than just the symbols. You're losing indigenous knowledge that is carried through that language as well. In many cultures around the world, you will find that there is a saying that you really can't translate some concepts. You have to say them in the language because they carry so much information. And you find this that sometimes if you're thinking about something to say something to a person in your local language, and now you have to translate it, you have to now convert the sentence into a paragraph because you're also trying to provide the context so that the person can understand what actually you are saying within these things. The thing to really understand when it comes to this is that the longer we wait in resolving these issues, this social data challenge, the more expensive it becomes to tackle. So the less, the more you're like, oh, we'll do it next year or 5 years from now. To deal with this, it becomes harder and harder, right? In South Africa, for example, government and higher education had commitments on developing local languages, but they keep on being kicked down the road. And a good way to think about this is like having a high interest credit card, right? The more you wait to pay it, the more expensive it becomes to pay the debt. And then ultimately you end up saying, no, I'm not paying, and declaring bankruptcy. And for languages, what this means is that language then ends up really moving closer and closer to extinction. So in this next part, I'll talk a little bit about what we do at Data Science for Social Impact when it comes to this. The other parts, like I do also, I'm a co-founder of a startup company called C4AI, and we do some things on that side, but on this one, I'll talk from the university side. So this is just kind of a different parts of ways to deal with low resourceness and what we've been doing over the years. So for example, here, this was some earlier work on thinking about how do we artificially increase the data that's available to us in natural language processing tasks by using augmentation. So if you think about images, I'll just give this an example. It's very easy to think that you've got some images. So even if you have one image, you can do things like flipping it, rotating, cropping, changing some color, doing removing some artifacts, adding some artifacts. And now you can go from one image to 10 images just because you can do that augmentation. The same types of things you can do in text, but you have to think about this and how you do it. And augmentation can also be used as regularization because it provides actually some diversity in these spaces. So just as an example, you could use WordNet, which has these syn sets or these kind of synonym sets, where you could take a word like in the afternoon, John is going to town, and you identify a noun, John, and going as what you want to change. And then you look for synonyms for the nouns, which is John, there could be Joseph, there could be Mary. And then you have the verb going, and you can have walking and running and other words. And now the output from the source there of John is going to town could say John is walking to town in the afternoon. So this is just an example. But then what it requires is that you must have this resource, which is this WordNet that gives you these syn sets. And for many, many low resource languages, this doesn't exist. I could ask for many of you on here, I don't know how many of you, for a local language, let's say outside something that's a bigger language like Portuguese or English, for a more local language, how many of you have dictionaries, thesauri, that you actually have and you use sometimes in writing in these spaces? And for a lot of times I ask that question, it's like one or two hands in a room of 20 or 30 people who have that, and that's showing that, like, you don't have access to this. The other thing that you could do at that, when we wrote this in 2020, you didn't have a lot of sequence to sequence models that could do translation, so we used Amazon, Google, IBM Translate. So we would estimate how much you're going to pay for that to do round trip translation, where you translate from one language to another and then back to do this augmentation. And then the thing that we were really wanting to test out was, could we use something like Word2Vec, where you can train word embeddings, and from those embeddings actually get the synsets, because what you just need to create this Word2Vec for that language is just gather as many documents in that language as possible and train these embeddings and then tune them to be as good as possible. So to evaluate this, we created a low resource scenario for English, where what we did is that we used a couple of data sets, the Sentiment 140, AG News, and hate speech. And then we ran all these different types of augmentations, and then also compared to mix up. So here, RTT to French means that we went from English to French and then French back to English. And you can see that one of the things that happens, that RTT for this is AG News, which is a news data set. The solid line is just the round trip translation. You have less error. And then once you add mix up, which is almost like a regularization augmentation, you get even much better performance in there. But the thing that was nice is that you could see, even with Word2Vec, you were getting a boost much better than just doing no augmentation, where you would have higher error in these spaces. This was for a logistic regression. This is for a deep neural network. And you can kind of see, again, mix-up gives you good regularization, and not doing any augmentation, you overfit faster, and then having some augmentation, you still go down. And you can read the paper for kind of more results within these spaces. Perfect, yeah, if you had synonyms, but for most things you don't. And if you then kind of looked at other spaces, one of the things you would have to do is create more kind of WordNet resources, and that's one of the things that we've done in the past as well, to do WordNets for South African languages and converting them. But for many languages, these might not be available. Word2Vec is interesting and very good, and you could also do adding on top of that mix-up. And with this, we also created a nice Python library that you can still find called TextAugment, that gives people access to these tools, and then they can try it and add them to their languages, their language tasks as well, right? So it's not just the papers we're writing, but then we're also releasing tools for people to use on that side. So that's one, is augmentation. So you can artificially try to increase your data. The other one was actually going and finding more data. And this work was from last year, where we were trying to prepare from South African government content how to get more data. So we wanted to liberate textual data. I talked a little bit about this, about access to data for research. So we wanted to get data that's coming from the South African government. You want to align sentence pairs that are in two different languages, automate it as much as possible, and then see if we can create new benchmarks for things like translation. So the data we used, our parliament, when they sit, the cabinet, typically after a sitting, there's a statement that gets released, and normally within a few weeks, those statements are actually translated, not just from English, but to all other South African languages. So we created a simple what's this payload? It's a JSON payload that has the data. It gives you the date, the title in English, and then you have a language payload for all the other South African languages. We have 11 official languages in South Africa. 12 official languages, including English and then South African Sign Language, and the written ones that are 11 of them. So you then have, for each of those languages, you have availability. For when the work was done, we had 162 statements up to December 2022. And this is automated. So every Friday, I think it runs and checks if there's a new statement, and then extracts it and then creates a payload. The other one was to get access to a government newspaper. There's a newspaper that gets released twice a month, and this typically gets released as it gets printed once a month, but then the PDF twice a month. And the problem with it was, if you had, for example, in the English version, you might have 20 articles, only 2 or 3 articles would actually be translated into the rest of the other South African languages. So it's almost like 10 to 15% throughput, right? So it's not a good, obviously, a situation. So you're saying, oh, we will have 20 articles in English, and then we'll only have 3 if people want to read in their language as well. So that's for civic education, it means that people don't really understand what's going on. The other issue is that PDFs are really bad for machine readability. So we had to then do a lot of manual extraction and cleaning. So we did this where we now converted all these kind of aligned articles into TXT files that had the title, an empty line, the author of the article, empty line, and then the body of the article. And you have them saved in those languages. Once you've done that, one of the things that we can do is also use embeddings. There's things like laser embeddings from Meta that allow you to give it 2 different sentences in 2 different languages, and it can tell you how close those sentences are in terms of similarity, even across languages. So if you have a high similarity, it's likely that it's just the translation of the same sentence, just in another language. And we know that these could be changed because we're coming from data that's actually translations. And if you do that, for example, you now can have, here's Vukosi Seswati 2,200 sentence pairs. Here's for the cabinet statements, and you have in Isindebele to Javenda has almost 19,000 sentence pairs. And if you've got this, yes, you can, in this case, it's just an example of a pivot using English. We can then actually do testing and actually run benchmarks to see how well we can get the blue score of translation. And one of the things that you notice is higher, kind of more and better scores, and also adding new blue scores that are not part of Achimoto is just one a data set that's available for some of the South African languages, and now we could add other ones. But the other thing that's interesting is that because we've done these sentence pair extractions, you can now use other languages as pivots. You don't need to rely on a high resource language like English. You could now train models in Isindebele to Venda, Northern Sotho or Sepedi to Seswati, which is something that becomes more important for people who are trying to really understand between those languages. And you can go, we do have the model on Hugging Face. So for example, this is for Seswati to English. Here's some content from our national broadcaster. And then if we run it through there, actually, it translates that into English. And it's mostly keeping the information correct. It's not 100% accurate, but it actually is telling us that, hey, our goalkeeper, Ronald Williams, and Percy Tau are confident that the team is going to compete well in AFCON in Ivory Coast. We ended up we went to the quarter the semifinals last year at AFCON, and it was earlier this year. So you can kind of create these tools that weren't there before, and they become useful kind of for people. And you can play around with this kind of model. Okay, that's fine. In these spaces. Right. Then this was some work that had been 3 years in the making, but we finally got it out last year at the end of the year. And this was then focusing on, hey, can we do an end-to-end process where we train a language model, in this case, a bird language, Roberta-based language model for one language, and be able to really look at the whole process that we had to do. And here, one of the things we had to do is curate as big of a Setswana corpus as possible. After that 3 years of work, we had 4.5 million articles, 25 megabytes on disk. Just as a comparison, for Common Crawl that's filtered in English, you're thinking about 9 petabytes. Remember, you have 1,000 megabytes a gigabyte, then 1,000 gigabytes is a terabyte, 1,000 terabytes is a petabyte, and there's Setswana at 25 megabytes. You also had JW300. JW300 was a data set from Jehovah's Witnesses. They are very much prolific translators for religious content, and just the JW300 was 19,000 articles, and JW300 was removed from the internet through a cease and desist. We had started this work earlier, but then we also wanted to show what the impact of JW300 being removed from the internet actually is, because for many languages in Africa, in South America, you might find that a majority of data that's that was available was through this JW300 dataset. And then we wanted to also compare against another model, which was NCHLT, built by another team in South Africa, which said that they had trained on 14.5 million tokens of Setswana. So as I said, we train a Roberta model, and this model is just to do masked prediction of missing words, and it was 3 days on a this is a Titan RTX machine for poor Bertha without JW300, 100 epochs, and poor JW300 was 40 epochs of training. And what we can do is then actually run different other benchmarks. This is Masakani NER, named entity recognition. So you can see there's poor Bertha 78.2 F1, poor Bertha plus JW300 80.2. So you get an improvement, but it was not as good as the big kind of cross-lingual model like AfroXMLR Large, which is out there, which was reporting at 89.4. But this is a tool now that's available for people who might want to use this that allows them to do name entity recognition in Setswana, and it's openly kind of available. This is for parts of speech. And what the thing that we see here is that these are the huge cross-lingual, multilingual models. They get up to 83.8, that's the best one, but poor Bertha plus JW300 is 84.1. And just for comparison, poor Bertha, the Roberta model is about 300 megabytes on disk. So you could actually put it on a phone if you wanted to in this space. And then there now you've got a part of speech tagging system that's available that has a good accuracy, and then people can also push this. There's some work within some collaborators inside the lab now to kind of think about poor Bertha 2, and then also Setswana-based kind of open LLM. The other thing that we did was get news data from the Botswana government in Setswana. They have a daily news service that also has Setswana space. We took 5,000 articles. Of those 5,000 articles, they were tagged. After tagging, you have all these different tags. We used the top 10 of those tags, and then we built up a model to predict these news categorization. So there's logistic regression and TF-IDF. You get up to 56.2 F1 in test, and then poor Bertha JW300 was the best with 65.4. Just normal poor Bertha was 62.9. So this is nice because then we do have a model that you can play around with, and you can put Setswana data. There's some text in Setswana talking about a court case, and you put it inside there, and then it predicts that this has to do with crime law and justice. So that just is giving kind of an overview of what we've been doing. There's a lot more work that's going on in our lab. It's worthwhile to visit our website if you want to just get a lot of what our recent work is. We're doing work on things like code switching or code mixing. We're doing some work in speech. We're doing there's as many different projects that are going on. And already for us, we've touched all the South African languages, and we're expanding into other languages and all these other types of building up resources, whether it's data modeling or coming up with new kind of algorithmic thinking to really deal with this challenge of low resource language. The last piece here before we open up for questions was then we then also need to have, it's not just about us as one lab, but then thinking about kind of building up a community. And here I want to talk about the deep learning Indaba. We started this in 2016 on working to strengthen African machine learning, where we wanted Africans to become critical contributors, owners, and shapers of these coming advances. Then when we're thinking about 2017, about AI and machine learning. So the thing that's interesting is that we've grown from the first meeting in Johannesburg in 2017, which was about 300 people, about I think 600 applications, to last year we were in Accra in Ghana, where we had 3,000 people who had applied to come to this research meeting, and it's had 800 people. And the Indaba has been really impactful in different ways, spurring on the African AI community. But at the same time, hopefully some of you might have already attended Kipu, which is like the South American inspired equivalent of the deep learning Indaba. And there's many other people who are looking at this and saying that you can actually build up grassroots driven communities where people really, get to a space where they can learn, teach each other, and really push forward these spaces. So as I said, last year we had 800 attendees. We were in Accra in Ghana. This year we're going to be in Senegal 1st to 7th of July. 200 grants, travel grants, and then 45% of the attendants were women, right? It's a very different type of AI conference, and because you're building it to really represent your community on that. For us, there's always been a lot of African AI, and there's much to learn. We still have to experiment our way into the future and how we work on this. It does need kind of a multi-sectoral push. It's not from one space to solve some of these problems. And there's a lot of things to think about in policy making, in making sure universities are supported, in creating local private sector that also invests in R&D in these spaces. But these things have to be done at the moment everywhere all at once. Like, everywhere. It is not just choosing a slice, because there is a challenge that if we don't work to really make sure we're counted in different ways, we are going to really be so behind that you can't really make the changes that you want, or to really represent the communities that you come from. So for us, thanks to all of our collaborators, we work with a lot of different people, because we really care about making the impact that we want, the languages, and really making sure we understand the communities we're trying to serve in general. And we're also very thankful to all of our sponsors who sponsor our research group and lab. Without them, it would be very hard to really get to a lot of the results that we have, and we're really thankful for that. So I think with that, I will maybe stop for questions, and thank you also for having me.
Very nice. Thank you for the talk. And we have an audience here. Maybe people are interested in questions. I will just start. So we have a discussion in Brazil as to what kind of infrastructure the government should provide, whether it should provide compute to people, to universities. There is an ongoing debate in other countries as well, right? What is the minimal infrastructure that should be provided? Do you have that sort of discussion happening in South Africa in some way?
We're definitely having the same. Oh, sorry, we're having the same conversations here, because there's the part of thinking about national shared infrastructure in compute. But maybe my feeling in the short term is that chasing the compute side is hard, is much harder, because the lead time to even get some of it now is over a year, right? So even if you were to order it today, you would have to wait because there's such long queues of people trying to get these things. At the same time, the reason, as I said, we did the work with the Roberta, is showing you that there's still so much you can actually do with focusing on much smaller models. And because for a lot of the languages, the basics just don't exist. So if we're just thinking about, oh, we're going to build another LLM, sure, it's a very interesting technical problem to kind of get that right for the, but how much could you have done for how many languages, even with smaller ones? I think our CEO at Lilapa says, we're working to build tiny models that are useful for people.
Okay, well, thank you. Any questions?
Hello, Vukosi. This is Adam. How are you doing?
Hi.
Yes. So.
Hey, how are you doing?
Yes. We have a collaboration, right? So thank you for your talk. And what the Professor Cosman just asked is also an anguish we are sharing here, because so I heard you talking about shared infrastructures. That means should we think about shared infrastructure in the global south, for example? Because when we think about having the same infrastructures as Amazon, Meta, Google, we cannot. And another problem of this is we don't have a planet to use the same resources they are using in terms of energy and everything. So this is one thing I'd like to know. How can we collaborate, and how your discussions are, are touching this about sharing infrastructures and thinking about these. And I have many other questions, but I will leave for the colleagues here also to interact. Thank you.
Also, let me use the microphone to say that we have a remote question from a person from the audience remote. And Andy also asked about how to foster South-South collaboration. So maybe that's a related issue that you might explore. Thank you.
Sure. Yeah, I'll answer both. And thanks for the question. Yeah, I think it's very important. So we worked about 2.5 years ago. We were working. I think it's almost 2.5 or 2 years ago on the African Union Development Agency's white paper on AI. And one of the very big parts of thinking about that was data infrastructures. So even the compute side. And one of the things was, you have a lot of countries that don't have complete energy security. They don't have meaning their citizens don't have good access to electricity. So trying to push and just saying, yeah, what you should do is actually get good electricity so that you can power GPUs doesn't seem like a good a good idea, right? While the basics of people just having much better lives is just ignored. And this is a thing that we need to think about. At the same time, the amount of energy that's used by these types of systems is having an effect on our climate, right? It will have an effect on our climate. So we must think about the way that we do it in a more considered way. We're having to balance between lots of different things. I might think about having a small cluster of 4 machines in my lab, and then having access to some GPU somewhere else through another service. And then we use a lot of different ones. And then we also have a national HPC, but they pale in comparison. That's what I'm saying. Like, I'm not going to think about, we're going to build a multi-billion parameter model just so that we can show that we can do it. Because it's like, is it fit for purpose? Does it really touch on the needs of the communities and what they what they're saying they would find very useful? And in some ways, it's been hard to justify some of these things, because it's either nation states just saying, oh yeah, we want to show that we can also build our own LLM. And that's a concerning kind of thing of just choosing those types of directions. But the shared infrastructures could allow us to think more carefully of like, where's there good electricity? Where's there better internet connection? How do we make sure that it's much more sustainable? Is it coming from sustainable sources, and allowing us to do that? But if everything just becomes about the output is about, hoarding power or money, this is where I think it's going to be problematic. On the side of the South-South collaboration, there's a lot to share. The reason I highlighted Guiwa Tiongo's work, where he tries to situate why, the challenges with our language development, it's because this is something that we share, right? A lot of us in the South share these histories of being stripped of kind of ourselves as part of these colonial kind of expansion projects. And this actually affects our language as well. So the thing is, we can do better South-South collaboration because we understand each other's backgrounds much better, than a person who's not gone through the same effect on their languages as well. So that is a thing that we need to do. And that's why we were very happy at the Indaba when we saw Kipu Kipu starting for South American kind of AI. And at the same time, we had Masakane, which is a research distributed research foundation for language. And now you also have America's NLP. They actually had their sessions, I think, last week or the week before at one of the NLP conferences. So for us, this is a thing we would want to always be connecting and building each other up.
Okay, thank you. Any questions here? So I got a question from WhatsApp. WhatsApp. It's a question about spoken languages. So you talked about projects that address written languages and written corpora. Do you have any insights on spoken African languages?
Yeah. I'll speak about what I'm like allowed to talk about for now. But there are projects that are going on that will come in soon. But yeah, speech has been a big challenge. There's more that's coming kind of along. There's been the Mozilla Common Voice project for people who are interested in looking at that, and that's creating open speech data sets for on the African continent. It's covering, I think, a lot of Swahili, a bit of languages from Rwanda, but that's a major project to make speech data available and many things on in their spaces. At Lilapa, we are building also ASR systems for African languages as well. API is available now, so you could go to lilapa.ai to see some of the work that's been going on there from the company side. And there will be, I think, by early next year, there's going to be kind of, I think, more data that has to come to speech, especially speech kind of transcription. But the thing to also note is that there's many languages that don't have written forms. So there's still also a lot of requirements to think about speech to speech, speech analytics without having access to text as well, right? So that's another thing that is worth studying in different ways. The other piece when it comes to these other modalities is also then thinking about there is then these requirements that are not really AI related requirements that people might be trying to study language, study culture, and making that as we're doing our work also on AI, we also make sure we leave artifacts for other people that they can use in their studies as well. Right. So not everything is on the part of making sure we pass it through a GPU. There are other parts of like, scholarship that are looking at these things. And as such, knowing that this actually is a need is very important. So like, more multidisciplinary or transdisciplinary research needs to be done in these spaces.
Okay, thank you. One last question, maybe?
Yeah, so some of the questions is one I'd like to know, when you think about translation, how do you think people who are speaking indigenous languages, spoken languages, how do you think they will benefit from these, these kind of translations with English, for example? And the process of digitalization you were talking about, which is reducts the language, because the language is much more than codes, it's culture. So how you were facing those challenges, and what you could share with us, like the most difficulties and challenges, etc. Thank you.
Yeah, that's a good question. So I think in general, globally, making more tools available that have pivots, so the language that's connected to the translation, not being English or German or French, is very important, because we can also now start learning the connections actually between the languages. There's been some work, especially on the tech side, for Masakani NER, Masakani POS, that showed that you can actually gain performance because of being able to trace geographic and cultural similarities within the languages. right? So this is very important, and that you wouldn't really capture if you were just everything going back to English, or everything going back to French or German in these spaces. So there's things to learn there, right? And this is research worth doing. The other piece is also mapping the things that come from social sciences, of mapping our migrations, mapping the connections between communities and all those things. We can now also think about how computing assists in those areas in providing other information, or also informing the way that actually you should actually create models. Why is this important? So you actually, the choices we've made in modeling, like the LLMs use byte pair encoding. Yes, it's good for languages like English, but there's other languages that are not well represented by that encoding that is used in LLMs, that they're like the more popular ones. And there's other encodings we actually have to learn, or we have to develop to better actually support these. So for example, isiZulu, I think there's a lot of work on segmented models to build, like, to try and actually build much better models that actually get much. They might not be at the moment at the same type of efficiency as byte pair encoding, but you only will get better efficiency if you do the research in that area, in that language, right? The work in their spaces. So there's still many things for us to learn. It's not that because a ChatGPT or or a Gemini exists, that it means that these issues have been resolved for all languages. It's for some, and normally it's very few comparatively to everything that we have that's out there.
Okay, Professor Marivate, I think we're reaching the hour. So we'll have a coffee here, a party to celebrate the end of the semester. Unfortunately, you cannot come, but I hope you will come at some point and visit us. We'll be happy to have you here. Okay, thanks a lot. Congratulations for the talk, and let's thank our speaker.
Thank you. I look forward to it.
Okay, bye bye then. See you sometime.